Hi, this is Miss Fitzmaurice. So tonight for homework, what I want you to do is I want you to go to your Unit 2 packet. You're going to do the multiple choice questions on pages 15 and 16, but the way I want you to do them is I want you to do them without any notes, okay? And actually try to do them without any equations either. You want to spend on the 8 problems a total of 14.5 minutes, so time yourself. Then you're going to come back, watch this video to correct yourself, and in these margins on the side, you may have been wondering, what are these margins on the side for? What you're going to do is you're going to write your original answer, so my answer, the correct answer, and you're not going to correct it, but what did you miss? So I want you to reflect on whether you used the wrong equation or you didn't read a certain word that said something was at rest. What about the way you did the problem led you to get the incorrect answer if you got the incorrect answer? Alright? So again, give yourself 14.5 minutes. Do these without notes, and then check back for the answers to these problems. Okay, so now that you've given yourself 14.5 minutes and tried to do these 8 problems, go over the answer. Again, as I go through them, make sure that you take note of your answer, the right answer if you did not get it correct, and what you missed. Okay, this is really important. This will help you learn from this rather than just feeling like, oh no, I'm not very good at multiple choice. Okay, so number 1 says, a diver initially moving horizontally with a speed v dives off the edge of a vertical cliff and lands in the water a distance d from the base of the cliff. How far from the base of the cliff would the diver have landed if the diver initially had been moving at speed 2v? Okay, so one thing we could do is that we could first of all, we know this is a two-dimensional motion problem, okay, and we know that the diver is diving off this cliff initially moving horizontally, so we know at the beginning all of the speed is in the x direction. Okay, so we can do this in general and then compare what happens to d, the distance, and I'm going to call it x instead of d, just so we have something to plug into for a generic 2v or 4v or 17v that we plug in. Okay, so what I'm going to do is I'm going to solve this equation, or this problem, in terms of variables. So we have, as usual, we're going to label all of our x's and all of our y variables. And I'm going to pause this while I do this, because I'm sure you already did that. Alright, so what I've done here is I have made a list of all my variables and I've labeled them. So I said that my starting x position was 0. Okay, I said my final x position was x. I just needed to give it a name that wasn't d. My initial x velocity, and that's the total velocity, I called just v naught x, and I knew because the thing was moving horizontally at the beginning, v naught y was 0. Okay, I know there's no acceleration, despite what may have happened in the physics fight, in the x direction. I know that in the y direction my acceleration is negative 10 meters per second squared, and I don't know the height of the cliff, so I just gave it a name h. Okay, I know that in both situations, the height of the cliff is the same because they're talking about the same cliff. So Now what we can do is we can go ahead and we can write an expression for we can find an expression for t, and then we can write an expression for x, which is what we're trying to find at the end. Okay, so looking at these two sides, I see that I have more information in the y direction, so I'm going to use that information to solve for time. I can write xy equals x naught y plus v naught yt plus 1/2 ay t squared. Okay, I know that xy is 0 and v naught y is 0, so those two terms go away, and I end up with 0 equals h plus 1/2. I'm going to actually leave this -10 as g, t squared, and the g just stands for acceleration due to gravity. I do a little bit of algebra and solve for t, and I end up with t is equal to the square root of -2h over g. Okay, so now I've found time, and I can put it into the x direction. Okay, and I'm going to go ahead and use the first equation again. I have xx equals v naught xt plus 1/2 ax t squared. Okay, I know there's no acceleration in the x direction, so that term goes away, and I end up with x is equal to v naught x times the square root of -2h over g. Okay, now I can say, so for example, in the first case we had d equals our initial v times -2h over g. In the second case, we would have some new d, I'm going to call it d prime, is equal to 2v times -2h over g. Okay, I can see that this, that I put in parentheses, is the same as d, so my new distance, d prime, is equal to 2d. Okay, so looking back at all of my options, we can see that C is 2D. Okay, you could have done this without all of the algebra if you had realized that for both cases, okay, the amount of time that something takes to fall, because there's no initial y velocity, is just going to depend on the height. Since the height is the same for both, okay, we can immediately jump to v naught xt as x and realize that since the time is the same, if I have 2v, I will have 2d. Okay, so you could have done it out this very long way, or you could have figured it out in about 2 seconds. Alright, so number 2 and number 3 are about the same picture. Okay, in number 2, we have this ball, and we want to compare the size of the velocity as it flies through the air at points P, Q, and R. Okay, and if it's asking about the size of the velocity, and we have a velocity that is not straight up and down or straight side to side, it's asking about the hypotenuse of our velocity vector. Okay, so that's technically that's the length of the vector. Okay, that's the total velocity. Okay, so we know, because acceleration in the x direction is equal to 0, that at points P, Q, and R, each of these points, we will have the same Vx. So I'm going to actually make this big enough for us to draw on. And at point P, we have a certain Vx. At point Q, we have the same Vx. And then again at point R, we have exactly the same Vx. Okay, and that's because Ax is 0. In the y direction, we know that Ay is equal to negative 10 meters per second squared, or if we want to be specific, negative 9.81. Okay, and so what's happening as this ball flies through the air is that the y velocity will change. At point P, we have a certain amount of y velocity going upwards. At Q, we have no y velocity, and at point R, we have the same y velocity, the same size y velocity as we did at P, except it's pointing downwards. Okay, so if we only have a vector that points in one direction, side to side, okay, this is the total length of our velocity in the case of point Q. Okay, it's all side to side. We have this hypotenuse is the total velocity at point P, and this hypotenuse is the total velocity at point R. Okay, we know at points P and R, the sides of our velocity triangles, the components of our vector are the same, and what that means is that VP is the same length as VR. Okay, VQ is smaller because it's just the side. It's the same as this. Okay, it's the same Vx that we had before, and the hypotenuse is always the longest side of your triangle. Okay, so in terms of our choices, we know that VP equals VR, and they are both bigger than VQ, so the correct option is option D. Alright, in number 3, we have the same picture and situation. A ball is thrown through the air, follows a parabolic path, and what we want to know is which of the following diagrams or arrows best shows the direction of the acceleration of the ball at point P. Okay, so just like velocity, acceleration is a vector, and in order to answer this question, we need to be able to answer what is AY and what is AX. Okay, we know AX is 0 because this thing is in the air, there's no side-to-side force acting on it, and we know AY is equal to negative 10. Okay, what that looks like in terms of a vector is nothing from side to side, and then a downwards arrow for AY, and this is option D. For number 4, we have two vectors, v1 and v2, and they have the same magnitude, okay? What that basically means is they have the same length, or the same size. Okay, the vectors represent the velocities of an object at time 1 and time 2. The average acceleration of the object between time 1 and time 2 was A directed north, B directed west, C north of east, or D north of west. Okay, so in order to think about this, we need to think back to the definition of acceleration. We know that acceleration is equal to change in velocity divided by change in time. or at least average acceleration. Okay, in this case, we start out with a velocity vector that is northeast, and it looks like it's exactly northeast, and then it's moved this way, okay, so that it becomes straight north. Okay, in moving this way, that change is, in fact, a westward change and a northward change. Okay, so the correct answer in this situation is D, directed north of west. Okay, another way to think about this is that delta V is V2 minus V1. Okay, what we can do to represent subtraction of vectors, we have V1 it's really V2, I should have gotten rid of that, it's V2 minus or plus negative V1. Okay, so here are two vectors. V2 is right here. Negative V1 would look like this. Okay, it would just be opposite of V1. Okay, so if we had a vector that was V2 plus negative V1, that vector would have to be from start to finish directed north of west. Alright, so in number 5, we have a target T and it lies flat on the ground 3 meters from the side of the building that is 10 meters tall, as shown above. Okay, so this is our picture. A student rolls a horizontal ball off the roof of the building in the direction of a target. So this is our picture. We know our ball is rolling horizontally and that we have a target some distance away. And we want to know, what does the horizontal speed have to be in order for the ball to hit the target? Okay, so we're going to go ahead and make an X and a Y chart. So our X information and our Y information. And I'm going to pause this while I fill those out. Okay, so I'm going to set my initial X position to be equal to 0. I want to hit this target, so I want my final X position to be 3 meters. I don't know my initial X velocity. I know my initial X acceleration is 0. Okay, I know my Y velocity is negative 10. My initial Y velocity is 0 because this is rolled horizontally off the building. Okay, I know that the building is 10 meters tall. Okay, so that's 10 meters is the height. That's my initial Y position, and it falls to the ground, so my final Y position is 0. Okay, looking at my two sides, I can see I have more information in the Y direction, and I'm going to use Y to find time. Okay, I can use my first equation, so I'm going to do this in Y. I have xy equals x naught y plus v naught y t plus 1/2 ay t squared. Okay, we know that xy and v naught y are 0, so these two terms will go away. Alright, so we have 0 equals 10 plus 1/2 negative 10 t squared. We can go ahead and solve for t, and we should end up with t is equal to about 1.4 seconds, which is also equal to the square root of 2. Okay, now we can plug this into our x information, and we have xx equals v naught t plus 1/2 a t squared. We know there's no acceleration in the x direction, and so we can go ahead and plug in xx, which we want to be 3. So we can plug in 3 equals square root of 2 times v naught, and v naught is equal to 3 divided by the square root of 2. Looking over at our options, that is option C. So the answer is option C. Alright, so in number 6, we have an object. It's thrown with a velocity v from the edge of a cliff above ground level. Okay, we want to know what we have to do, so what angle we have to throw it in order to get the maximum range or the maximum distance from the cliff. Okay, we know that if you shoot something at 45 degrees from ground level, that it will go the maximum distance. Okay, so if we shoot something from 45 degrees, that is the maximum range it can have if it is returning to the same place. On the other hand, if we shoot something from less than 45 degrees, we know that it won't go quite as far, but with the same speed it'll have more x velocity. Okay, so if we have the same length vector, a 45-degree angle versus a smaller angle, okay, if these two are the same, then the one that has the smaller angle will have the more horizontal velocity. Therefore, even though at the height of the cliff it came from, it wouldn't have gone as far. It would go further if it were less than 45 degrees because the angle is smaller, there's a larger x direction. Okay, so what this means is that the option here is C. Alright, in number 7 we have an object. It's released from rest, and we know that in the first second it falls a distance h. We want to know how far it will fall in the second second. Okay, so one thing we can do is we can go ahead and we can say in this first second it fell a distance h. We want to know how far it's falling here, okay, in our second second. So instead of labeling the ground 0, I'm going to say that our initial position 0, after 1 second we've fallen to negative h, and then after 2 seconds we've fallen to some distance negative x. If I can find what that negative x is, I can subtract it from h to find how far it fell during the second second. Okay, because this is 0 seconds, 1 second, and 2 seconds. We're looking for this distance right here. Okay, so to do this, I'm going to use our first kinematics equation. We have x equals x naught plus v naught t plus 1/2 a t squared. Okay, it says it is released from rest. What that means is that v naught is equal to 0, and after 2 seconds, we can plug in t is equal to, t is equal to 2. So we're going to solve for x, and we have x is equal to 1/2 a 2 squared. That's after 2 seconds. We can do the same thing for 1. We have x is equal to 1/2 a 1 squared. Okay, we can simplify this expression and we end up with 4a. Okay, for 1 second, we simplify it and we get 1/2 a. Okay, since this is equal to h, just by definition of the problem, we know that 4a, if 1/2 a equals h, then 4a has to be equal to 8 times h. Okay, and what that means is in the second, this should be 2a. So 2a is equal to 4h. So we have 2a is equal to 4h. Okay, we know that that's the total amount that we've done, and the difference between 4h and h is, of course, 3h, which is option C. Alright, so finally, in number 8, we have the diagram showing 4 cannons firing shells. They have different masses and different angles, but actually the maths shouldn't matter. And so what we care about is their angles. Okay, we know that in each case, the horizontal velocity is the same. Okay, and if you think about solving for xx, which is the range, okay, anytime it says range, it's really asking you about xx, you can probably guess at this point that you're going to be plugging that into v naught x times t. Okay, so if you want to know which one has the biggest range, you need to think which one, since they all have the same vx, which one has the biggest t. Okay, and the one that's going to have the biggest t, the longest time in the air, is actually the same one that has the largest y velocity. Okay, this makes intuitive sense. If you throw a ball up into the air, if you throw it with a bigger initial velocity, it'll be in the air for a longer time. Okay, looking at these options, cannon D has the biggest y velocity, so it will have the biggest t, and it will have the biggest xx, or the biggest range. Okay, so the correct answer is cannon D. Okay, so take a minute, make sure that for each of these problems you've responded to what the correct answer was, and if you did not answer correctly the first time, what you missed. See you tomorrow in class.